So let's start the session. Yesterday we discussed about the data warehouse fundamentals. So today let's start with the data stage fundamentals. So as part of the data stage fundamentals, so I'm going to explain the introduction of the data stage, the architecture of the data stage components, jobs and types, stages, links, and parallelism. So these are the different topics today I'm going to cover as part of the data stage fundamentals. So first of all, what is a data stage? So as I explained earlier, so data stage is an ETL tool, so which is used to extract the data from different types of sources, and we can transform the data as per the business logic, and we can load the data into any of the table. So that table will be present in the data warehouse. That means it's a database. So data stage makes extraction simple to design and develop efficient applications. So why it is simple is, so we don't require to write any SQLs or PL by SQL programming or any scripting languages or any programming languages. So it is completely a GUI application. So we need to just drag and drop the stages in the data stage, and by customizing the different options in the data stage, we can simply extract the data from any types of the sources. And also transformation is also very easy just by using the drag and drop methodology. So we have almost all the transformation activities, transformation techniques available in data stage. So as per the business logic, we can perform any type of business logics simply by dragging and dropping the different options in the data stage. And also loading also very easy, just it's a drag and drop methodology. So as I said earlier, so data stage is completely a drag and drop methodology. So we don't require to run a single line of code using the data stage. So coming to the different versions of the data stage. So data stage is started with the essential. So essential is the organization, so which is invented the data stage first. After that, after few versions, so IBM took over the data stage, and now, so the name of the data stage is IBM WebSphere Information Integration Server. So it is a suite under the data stage is one component. So this is just an introduction of the data stage. So coming to the architecture of a data stage. So it is also like other technologies. So it is a client server architecture. So we have a different client components. We have three client components available in data stage: administrator client, designer client, and the director client. These three are the different client components we have. And we have a parallel engine and server engine. This is the engines. So when Essential invented the data stage, that time we have only server engine. After that, parallel engine is a new concept. We can execute the jobs parallelly. So that has been introduced into the data stage and implemented in the data stage. So now we have parallel engine and server engine both. But we are not completely using the server engine now. We stopped it. So we are using only the parallel engine because it is an advanced technology. So whenever we raise any request in the client components, so it will connect to the server and it will fetch the response. And if you see this right side, the bottom one, so it is a shared repository. You can see the diagram. So it looks like a cupboard. There are different things are present in the cupboard. So the usage is also same. It's like that. So we can save whatever the programs we create in the data stage, we can save it in the repository. So it is a shared repository. It's a storage area where we will store all our programs, all our components. Okay, so this is the client server technology. Here we have three different types of sources. So the first, three different types of clients. So the first client is administrator client. So by using the administrator client, we can create the projects, we can set up the project level properties, and we can create the environmental variables. So the main usage of the administrator client is we can set up the project level properties. So if we change any property in administrator client, so it will impact the entire project. So after creating the project in the administrator client, we will log in into that project using the designer client. So actual designs will be implemented in the designer client. Okay. So this designer client is a window where we will exactly do the coding. So after that, after designing the code, so in any language, in any programming language or in any tool, after designing any code, what are the next steps? So we need to compile the code and we need to execute the code. So after executing the code, there might be different chances, like a code might get failed or it might get succeed. So that results we can verify in the director client. So it means we can check the log files using the director client. So the order is like this. So first we will log into the administrator client and we will create the project. It's a one-time activity. So after creating the project, we will use that project in the designer client to log in, and we will implement our designs. We will create our programs. And after that, after executing the programs, we can check the log files using the director client. Okay, so whenever you say you click on the save, or if you want to track some item here, so that will connect to the server and it will fetch the response. It's a client server architecture. So client side we have different components, and server side we have a engine. Any questions?
No.
So these are the different components as I discussed earlier. So this is the designer, director, and the administrator. These are the client components. And server side we have a DataStage server and the repository. So server is server is the server where we execute the actual code, and repository is a storage area where we will store all our programs. So let's take an example. And discuss further. So in my source system, I have a table. Okay. So the table is we'll draw here. So let me write. So in my source, I have 4 columns. For example, let us assume. So in my source, I have customer table. So in my customer table, I have a customer ID, I have a customer first name, I have a customer last name, I have a customer gender. Okay. So in my target, uh, I have a customer underscore dimension table. So in this table, I have a customer ID, I have a customer name, I have a customer gender. Okay. So see, in my source I have 4 fields, but in my target I have only 3 fields. So customer ID, first name and last name, here I have only name. It means I want to get the customer name from the first name and last name. So how to get that? By concatenating the first name and last name, we can get the customer name. So that is one transformation I want to perform. And third step is customer gender. So this is the customer gender. So my requirement is I want to fetch the data from the customer table. This is the input, and I want to load the data into the customer dimension table. So to implement this particular scenario, so let me show you how to design a job. See, so there are 3 boxes you can see. So the first and foremost step is we need to extract the data from customer details table. We need to extract the customer details data. So like 4 fields: customer ID, first name, last name, and gender. Okay. After extracting the data, we need to transform the data in the second step. So what type of transformation required here? we need to perform the concatenation operation for customer first name and last name to get the customer name, right? This is the concatenation operation. This is the transformation rule. And third step will be loading process. So in the loading process, we will load the customer ID, customer name and gender into the customer dimension table. That is the target table, right? So these are the three steps we need to perform to satisfy this particular requirement, right? So to extract the data from a customer details table, or to perform the transformation logic, or to load the data into a customer dimension table, here there are different boxes. You can see these blue color boxes. So these boxes are nothing but stages in DataStage. So DataStage, the tool name itself, it's a DataStage. So these stages are used to extract the data from any type of a sources, or to perform the transformation activity. So by using the stages, we can extract the data, or we can load the data, or we can perform the transformation activity. So a stage can read, write and do the transformation activity. So here there are two types of stages in DataStage. So let me move to the next slide so that you will get the information. So stages here. A stage defines a database, file and a process. It means we can define a database. It means we can extract the data from a database, or we can define a file. It means we can extract the data from a file, or we can load the data into a file. And process. So what is the process means? The process means we can do some transformation activities, like transforming the first name and last name to a customer name. So that is the transformation activity. That is called as a processing activity here. So there are two types of stages. One is the built-in, second one is the plugin. Built-in stages means when we install the data stage, whatever the stages we will get while installation, those stages are called built-in stages. So apart from that, for example, I want to perform some transformation activity, like I want to perform sorting operation. So I don't have a stage available to perform the sorting. Then data stage has a facility to create our own plugin stages. Okay, those stages are plugin stages. We can create any of the stages, but normally most of the times we can find whatever the required stage in the data stage itself. We don't require to create any stages, but still we have an option to create our own plugin stages. And in the built-in stages, again we have two categories. One is the active stage and second one is the passive stages. So active stages means, so if you see the previous example, in the first stage I am just reading the data, nothing more than that. So this stage is called as a passive stage. Whatever the stages we will use only for reading and writing, this and this, first and last, these stages are called passive stages. So in this middle stage, in the transformation activity, I can, so I'm doing some processing activity, like I'm just concatenating the first name and last name to get the customer name. It means I'm working on some structure of the data. I'm modifying the structure. It means concatenating the first name and getting the name. So if I perform a particular operation rather than simply extracting and loading, so that is called as a active stage. The name itself, it's a self-explanatory. So this is the stage. So if you see, this is extraction, this is transformation. We are using one stage to extract the data, one stage to transform the data. So how to pass the data from one stage to another stage is by using the links. See, there is a link in between the two stages. So this link only actually carries the data from source to target. So source, here source means this extraction, transform this load, source to target. So target means this transformation. So this particular link will carries the data from extraction to transformation, and this link will carries the data from transformation to loading part. So this link only carries the data from source to target. So again, links also, there are different types of links. So if you see, there are basically three types of links. So it's a normal plain arrow. So this is the primary link. This can be connected in between any of the stages. We can connect to any stages. And the next one is dotted arrow. So there is a dotted arrow. So this dotted arrow means this is the reference link. So this is used only to perform the lookup operation in the data stage. So if you want to perform the reference operation, for example, if you consider the employee and the department data. So if you want to check this employee is present in the department or not, if you want to perform this kind of reference operation, then we need to use the reference link. So this is not supposed, I mean, all the stages are not supported to this particular link. Only few stages will support to the reference link. And then third link is dashed arrow. So dashed arrow means it's a reject link. So this is a reject link. So for example, I'm trying to load the data into one file. But unfortunately, some of the records are getting failed because of the structure or some issues in the data. So if you want to capture those type of records, we can use this reject link. So reject link is also supported by only few stages, not all the stages. So these three are the different types of links we have in data stage. Any questions so far? So let's move to the important concept in data stage. So that is the parallelism concept. So how the parallelism concepts works in data stage. So there are basically two types of parallelisms. So one is the pipeline parallelism. So one is the pipeline parallelism. So how a pipeline parallelism works is, let's take some sample data. So I have a data like this. So I have few records. Okay. So I want to process these records. So how the processing will happen in the pipeline parallelism technique is, so first record will be extracted by the source stage, and then same record will go to the target. Meanwhile, second record will be extracted. So first record is processing in the transformation activity. Meanwhile, second record it is extracting. Again, first record will move to the target. So it means it will try to load the data into customer dimension table. Meanwhile, second record will be moved to the second stage. And meanwhile, third record will be extracted in the source. So if you see, at any point of time, each stage is executing independently. So each stage is processing one record. So three records are processing at any point of time. So this is called as a pipeline parallelism. It means, so for example, if you are processing the first record, so till it completes, these stages are not going to be idle. These stages will process the further records meanwhile, rather than waiting for the first record to be completed. So this is the pipeline. So pipeline means how the water flows through the pipeline. So the same way records will be flown through the stages, through the job. Okay. So here I forgot to explain one thing here. Let me go back. So as I mentioned earlier, so this is one stage, this is the other stage, this is the third stage. So by using these stages, by using these links, I'm just moving the data from one stage to another stage. So here, the complete thing, I mean, first stage, second stage, third stage, and together links. So this entire process, this complete thing is called as a job. This is a job in data stage. So a job means, a job is a graphical representation of data flow from source to target. So if you know the C language or Java, so we will create the programs. So a program is nothing but it's a step-by-step process to execute a particular activity. In Java or C language, we will call it as a programs, but in data stage, we will call it as a jobs. So this design is called as a job. Okay, going forward, everything we will call it as a job. A job nothing but It's a combination of few stages and links. Okay. So here I'm just trying to explain the pipeline parallelism. So pipeline parallelism flows the data like a pipeline. So all the stages will be executed individually. Okay. Rather than waiting for the first record to be completed. So this is the pipeline parallelism. And then, so partition parallelism. So what is partition parallelism? This is the most important concept in the data stage. So because of the partition parallelism, data stage becomes more popular nowadays. Okay. So here, if you see, there are three stages again here. So in Oracle stage, I'm just reading the data. In transformation, I'm just performing some concatenation function as per the previous example. And third stage, I'm loading the data into customer dimension. So how the data will be processed here is, if you see, the records are like this. So this is the records, okay. So it's a partitioning parallelism. How the partitioning parallelism works in data stage is, it will partition the entire data into some parts, in some groups. Each group is called as a node. Each group is called as a node. So here, how the processing will happen is, first stage, it means this particular stage, will extract the first record from each group. So it means it will extract 3 records at a time. Okay. Same 3 records will move to the transformation activity. Meanwhile, it will extract the second records from each group. Again 3 more records. Meanwhile, first 3 will go to the loading process. The second 3 will go to the transformation. Meanwhile, third records, each from each group it will extract the third record. 3 more records. So if you see, at any point of time, this particular stage is processing 3 records, and this is processing 3 records. This is also processing 3 records. In previous pipeline parallelism, we can process only 3 records at any point of time. Here we process 9 records at any point of time. Right? Any questions?
No, Naresh.
Okay. So here, as I mentioned earlier, so here I am dividing the data into 3 sets, right? 3 sets. That is the reason. So from each set it is extracting the data. So how can I decide that we will create only 3 partitions is, so in data stage we have a file called configuration file. There is a file. So this configuration file will be created by the data stage admins. So those people will see the, those people will create the configuration file, and they will decide this, in this configuration file they will mention that how many nodes needs to be created while executing any job. So that information will be present in the configuration file. So you can ask like, if we create 3 nodes, so we can execute 9 records in each. If we have 3 stages, right? So if you can create 50 nodes, we can execute some more faster, right? But that is not the case, because these nodes, if you want to create a more number of nodes, we should have the proper hardware available. We should have we should have the server capacity to maintain these nodes and run these nodes, because it's a parallelism processing, right? Parallelly, data will be executed. So all the nodes will be in execution mode. In active mode. So because of that, in most of the companies, we will use 3 to 5 or max 6 nodes in any company. So here, so in configuration file, we clearly mentioned that 3 nodes needs to be created. That is done. But these first 3 records are going to the first node, second 3 are second node, and these are third node. So data is dividing like that. So how can we decide that which record needs to be processed by the which node? For example, let's see I have a data like this. 10, 10, 20, 30, 20, 30, 20, 30 and 10. So I have data like this in my source. So how can we split the records into each node? How can we assign the records to the nodes? So that is depending on the type of partition we will use. Here you can see there are types of partition techniques. Let us assume there are three partitions we have. 1, 2, 3. Three nodes. How the data will be processed is, it is completely based on the partition technique we select. So these partition techniques needs to be selected in each and every stage level. So in source stage I have to select one partition. In target stage I have to select one partition. In source I have to select one. In transformation I have to select one. In target also I have to select one partition technique. So based on the type of processing, based on the data processing, like for example, if you are performing sorting operation, then one partition is the best. If you are performing some lookups, then one is better. Other partition. If you are performing remove duplicates, one partition will be better. If you are performing aggregation, another partition might give the better performance. So like that type of data processing we are performing, based on that we will select the partition technique. Here I am going to explain you the different partition techniques. So one is the round robin. So if I select the round robin partition technique, how the data will be assigned to the nodes is, it's like a playing cards. You know the playing cards, right? So first record will go to the first node, second record will go to the second node, third record will go to the third node, and then again start from the beginning. Fourth record will go to the first, fifth will go to the second, sixth will go to the third. Again starting. So like that. So each record, records will be processed like playing cards. So records will be distributed like that to each node. So this is the round robin methodology. So coming to the random. So if you select the random partition technique, how the data will be processed is, so we cannot identify the records assigned to each node. So 10, 10, these three might be go to first node, these three might be go to the second node, these three might be go to the third node. So randomly it will assign the nodes, it will assign the records to each node. Randomly it will assign the records to each node. Okay, so this is the random partition technique. And then hash partition technique. So in hash partition technique, how the records will move to the different nodes is, hash is an important partition technique actually. So hash is a key based partition technique. This is a key based. It means in our data, in our stage, we will have some columns, right? So one of the column needs to be selected as a key. So based on that key, data will be divided into different nodes. For example, this column name is some serial number. Okay, so if I select the serial number as a key, how the hash partitioning will work is, each key column, each key value will be assigned to each node. Like all the 10 records, 10, 10, this 10. All all serial number 10s will be processed by one node. All serial number 20s will be assigned to other node. All 30s will be assigned to other node. So same key columns will be assigned to the same node if I select a hash partition. So why it is required? So where it is the where we can select the hash as a partition technique is, for example, if you are performing a sorting operation, then hash is the best partition technique, because if you are performing a sorting operation on the serial number, if you use a hash as a partition, same key values like 10, 10, 10, all the 10s will be in one node only. All the 20s will be in another node. All the 30s will be in another node. So it is very easy to perform the sorting operation, right? It will give the better results. because all the records, all the serial number 10s are adjacent. So it is very easy to perform the sorting. So that is one example. And if you consider the aggregation, like for example, if I want to calculate the sum of salary for each each serial number, in that case also hash is the best partition technique, because if you group the each serial numbers in one node, it is easy to perform the summaries because all the records are adjacent. So this is the another partition technique. And fourth one is a modular. So modular means, so it is depends on the mathematics modular operation. It depends on the mathematics modular operation. So it means, so this is also a key based partition technique. So we need to select a key column. So after selecting the key column based on the row number, so it will identify the modular. So row number modular number of nodes. For example, if the row number is 10, it will perform the modular operation with the number of nodes. 10 modular 3, it means it will give the remainder as a 1. So it means the record will be assigned to first node. So based on the modular result, it will assign the records to the nodes. And then entire partition. So entire partition means, if you select the entire as a partition technique, then how the data will be assigned to the each node is, so all records will be assigned to first node, all records will be assigned to second node, all records will be assigned to third node. So duplicates will be here. So in each record we will have one set of data. In each node we will have one set of data. So this particular entire partition is used in one place in DataStage. That I will show you once I open the tool. So this is the entire partition technique. And then auto. So auto means, by default DataStage will select the best partition technique if you leave it as auto. So but here the best way is, it's always better to select a specific partition technique rather than leaving it to the DataStage, because if we leave it as auto in sort stage, for example, so what is the best partition technique in sort stage? It is a hash is the best partition technique, but I don't know which partition technique needs to be selected, so I left it as auto. Then in that case it cannot select the hash, because hash is a key based partition technique. It can select the it can select the partition technique automatically, but it cannot select the key value, right? We might have number of columns. It cannot the key value. It cannot take the key value. Because of that, if I select the auto, it will take the round robin or random. It will select the round robin or random. So that is the reason it is always better to select the specific partition technique rather than leaving it to the data stage. And then last but not least, same partition technique. So if I select the same partition technique, it will continue the previous stage partition technique. See, for example, this is a sort stage, for example. Let us assume this is a sort stage and this is the aggregator stage. Okay. So what is the best partition technique in sort stage? Here in sort stage, hash is the best partition technique, right? In aggregator is also hash is the best partition technique. So here, if we have like this type of situation in second stage, rather than selecting a hash, we can select the same. Same means it will take the previous stage partition technique. It will take the hash only. If you want to continue the same partition technique, then we need to select the same rather than selecting the partition technique again. Why? Because if you select the same hash partition again, DataStage thinks that this is a different partition and it will lead to the repartitioning. So it means, if I select the hash in both the stages, after come here this is the hash, here also hash. So after this particular stage, in this stage data will be split like this, right, into each node. And in the middle of the processing, it will collect the data from all the stages. It will collect the data from the stage, and again it will split the data based on the hash partition technique, because it is thinks that we have selected a different partition technique. So If you select the same partition technique, how data will be processed is, here it is a hash, here also I want to select hash. That's the reason I have selected a same. How the data processing will be, here we have already splitted the data like this based on the hash partition technique. So same partition will be implemented here. So same data will be processed in same node. So this data also. So we can reduce the repartitioning process by selecting the same partition technique if you want to continue the previous stage partition technique. So here as of now we discussed about the different types of partition techniques to split the data into different nodes, right? But here at the end of the stage, here in this stage, I want to load the data into a table or file, right? At the end of the job, I want to load the data into a table or file. In this situation, I want to collect the data from all the nodes like this. So data is present in the nodes, right? So I want to collect the data from each node. So to collect the data from each node, I have a collecting techniques available. Rather than selecting the partition technique, in the last stage, I want to select the collecting technique. See, types of collecting techniques. So again, it is a auto. Auto means by default data stage we select the best collecting technique. And if it is a sorted merge means it's a key-based collecting technique. If I select a sorted merge, it will ask for a key. If we provide a key value, based on the key value, it will sort the data and load the data into target. In a sorting order, it will fetch the data from 3 nodes. And then round robin. So round robin means it's like a reverse order of the playing cards. So earlier we distributed the cards, right? Now we will pick up the cards from each node. So it will read the first record from here. It will collect the first record from second node, first record from third node, then second records, then third records, then fourth records, like that. So ordered. So ordered means first it will take the entire first node data into the target, and then entire second node data, entire third node data. Like this, in a particular order of the nodes, it will collect the data into target. So these are the different types of collecting techniques. So we need to select the collecting techniques at the end of the job in this particular stage. All the remaining stages we need to select the partition techniques. So as I mentioned, remember one thing, we need to provide these partition techniques in each and every stage of the job. So it means we can use the different partition techniques in the single job also. In single job, for example, if we have 20 stages, we can use n number of partitions. I mean all these different partition techniques in each and every stage. Any questions so far? Any questions?